Welcome to my 51st tutoring session in A-level chemistry. In this video, I will explain the meaning and importance of atomic weight and molecular weight, and also explain how atomic weight differs from molecular weight. Kindly subscribe my channel, share, like, comment, and watch the full video. Atom is the smallest unit of an element. It has a central nucleus and contains positively charged proton and electrically neutral neutron with negatively charged electron orbiting around the nucleus in their respective shells or energy levels. I have color coded the subatomic particles. Now in case of hydrogen atom, the nucleus contains only one proton and one electron orbiting around the nucleus in their respective first energy level or the shell, which is also the valence shell of the hydrogen atom. Now here are some of the important highlighting facts about the hydrogen atom. The hydrogen atom has one proton in its nucleus with one electron orbiting around the nucleus in the outermost valence shell, that is the first energy level or the valence shell. Hydrogen atom is the first element in the periodic table and is the only element in the periodic table without a neutron. Now, these are some of the important highlighting features of hydrogen atom. Now, atomic number is the number of protons present in the nucleus of the respective atom, and in case of hydrogen atom it is 1 as it contains only one proton. Mass number is the sum of the protons and neutrons present in the nucleus of the respective atom, and in case of hydrogen atom it is 1 as there are no neutrons in the nucleus of hydrogen atom. Hydrogen atom contains only one proton. Therefore, its mass number will also be 1. An important point to note here is that mass number is not equal to atomic weight. These are two different terms. Let's find out how mass number is different from atomic, considering examples of hydrogen atom and carbon atom. Hydrogen atom, as I already mentioned, its atomic number is 1. It contains one proton in its nucleus. Mass number is 1 as there are no neutrons in the nucleus of hydrogen atom. But the atomic weight is given in decimals, that is 1.008. And in case of carbon atom, atomic number is 6 as it contains 6 protons in the nucleus. Mass number is 12 as the nucleus of carbon atom contains 6 protons and 6 neutrons. And therefore, the mass number is 12. But the atomic weight is mentioned in decimals, that is 12.01. So why is the relative atomic weight of hydrogen is 1.008 and the relative atomic weight of carbon is 12.01? That is, the relative atomic weight of elements in the periodic table are mentioned in decimals, not whole numbers. Now, atomic weight is the sum of protons, neutrons, and electrons. But we ignore the electrons due to their negligible mass. The mass number is the sum of protons and neutrons. So in case of carbon, it is 12. And in the atomic number in case of carbon is 6. So however, atomic weight is slightly different from the mass number because some atoms of the carbon element contains different number of neutrons or the varying number of neutrons, and these are called isotopes. Now the common isotopes of carbon are C12, C13 and C14. Now if you observe the symbols of the isotopes of carbon very closely, you will find that the atomic numbers are same while there is variation in the mass number, that is 12, 13 and 14. This variation in mass number is due to varying number of neutrons present in the nucleus of the respective isotopes of carbon. In case of C12, nucleus contains 6 neutrons. In case of C13, nucleus contains 7 neutrons. In case of C14, nucleus contains 8 neutrons. So it is due to the variation in the number of neutrons in the nucleus of respective isotopes, you end up with the 3 different isotopes of carbon, that is C12, C13 and C14. So atomic weights are in decimals because the relative average weight of isotopic abundance is considered. So therefore, the atomic weight of carbon is mentioned in decimals, that is 12.01 and not 12. So what you see in the periodic table is this. That is 12.01 mentioned as relative atomic mass and not 12. Because certain elements, they contain different isotopes, natural containing isotopes. And when we consider the relative average weight of these isotopes, we end up with decimals and not whole numbers. So relative atomic weight are in decimals, not whole numbers. And it is the average atomic mass of its naturally occurring isotopes. So in case of carbon, the naturally occurring isotopes are C12, C13 and C14 due to varying number of neutrons in the nucleus of respective isotopes of carbon. And what about hydrogen? The mass number is 1. Atomic number is also 1. So the nucleus of hydrogen atom contains only one proton and there are no neutrons. Therefore, both the atomic number and mass number in case of hydrogen is 1. Now there are 3 isotopes of hydrogen: protium, deuterium and tritium. And again, when you observe the isotopes of hydrogen, you will find that the atomic numbers are same while the mass numbers vary. The mass numbers vary due to varying number of neutrons in these 3 isotopes of hydrogen. In case of protium, nucleus contains no proton. In case of deuterium, nucleus contains 1 proton. In case of tritium, the nucleus contains 2 neutrons. The relative atomic mass of an element is the average atomic mass of its naturally occurring isotopes. In case of hydrogen, it is H1, H2 and H3, that is protium, deuterium and tritium. So what you see in the periodic table is the decimal value 1.008 and not 1. So atomic weight is the sum of protons, neutrons and electrons. And electrons have a negligible mass, so we kind of ignore it in the atomic weight calculation. And molecular weight, it refers to the sum of the atomic weights of all the atoms in the molecule. For example, in case of methane molecule, you find the carbon atom is covalently bonded to 4 hydrogen atoms. And therefore, 1 mole of methane contains 16 grams. So atomic weight of carbon is 12, hydrogen is 1. So when you sum up, you end up with 16 grams. But 16 is not the right answer. The actual molecular weight of methane is 16.04 grams and not 16, because we have to consider the relative atomic mass of the respective elements. And that is how we end up with 16.04 and not 16. So atom has a central nucleus containing positively charged protons and neutrons with negatively charged electrons orbiting around the nucleus. Their respective shells or energy levels. So when you calculate the atomic weight, you should sum up the mass of protons, neutrons and electrons. And each subatomic particle is considered as 1 unit. Proton as 1 unit, neutron as 1 unit and electron as 1 unit. And when you consider the mass of these units, it will be atomic mass unit. So mass of 1 proton will be 1 atomic mass unit, that is 1.673 into 10 to the power of minus 27 kilograms. Mass of 1 neutron is again 1 atomic mass unit, 1.675 into 10 to the power of minus 27 kilograms. So when you compare and contrast the mass of proton to that of neutron, you find that the mass of neutron is slightly more than that of proton. And the mass of electron is again one atomic mass unit, the value of 9.109 in 10 to the power of minus 31 kilograms. So when you consider the ratio of masses of these three subatomic particles in terms of atomic mass units, ratio is 1:1:1850. That is to say that the mass of electron is nearly 2000 times lighter than that of proton and neutron. And therefore, we'll kind of ignore the negligible mass of electron in the atomic weight calculation. So generally we don't consider the mass of electron due to its negligible mass. So atomic weight generally will be the sum of protons and neutrons, ignoring the mass of electrons. So in case of hydrogen atom, atomic weight is 1 as it has no neutrons in the nucleus, and therefore the atomic mass of hydrogen will be 1 unit, that is 1 atomic mass unit. But hydrogen atom is so small and minute that it can neither be perceived nor it can be physically handled. So it is not weighable in atomic mass units, but the quantity is weighable in grams. So we consider in grams because it is a weighable quantity using a weighing balance. So 1 mole of hydrogen is 1 gram, which contains Avogadro number of atoms. For further details on the mole concept and Avogadro number, you can watch my video on the topic mole and Avogadro number. In case of carbon atom, atomic weight is 12. So 1 mole carbon is 12 grams, containing Avogadro number of atoms. But as I already mentioned, the mass number is not equivalent to atomic weight. These are two different terms. So how do they differ? That is the atomic weight and mass number. Let's try and understand with the help of electronic configuration or the electronic structure of hydrogen atom and carbon atom. So mass number in case of hydrogen is 1, but its relative atomic mass is 1.008 because we have to consider the relative average mass of all the isotopes, that is protium, deuterium and tritium. And in case of carbon, you have to consider the relative atomic mass of, that is the average atomic mass of all the isotopes of carbon, that is C12, C13 and C14. And that is how we end up with 12.01. So when you are trying to calculate the atomic weight, you have to consider the average atomic mass of all the naturally occurring isotopes of the respective element in the periodic table. And when you are trying to calculate the molecular weight of a particular molecule, you have to take into consideration their relative atomic mass and not the atomic weight. And that is why the relative atomic masses is always mentioned in decimals for the respective elements if they exist in the isotopic forms, or if the element contains natural containing isotopes. So when you try and calculate the molecular weight of methane, you have to consider the relative atomic weight of carbon and hydrogen. So relative atomic weight of hydrogen is 1.008, carbon is 12.01. And when you sum up the relative atomic weights of these two elements with respect to the methane molecule, you will end up with 16.042 and not 16 grams. And to summarize the discussion so far about the atomic weight and molecular weight, so you try to understand the concept of atomic weight and molecular weight, their importance, and how they differ from each other. So electrons have a negligible mass, so we kind of ignore it in the atomic weight calculation. And atomic weights, as seen in the periodic tables, are mentioned in decimals because the relative average weight of isotopic abundance is considered. And therefore, the atomic weight of carbon is 12.01 and not 12. And the atomic weight of hydrogen is 1.008 and not 1. So what you see in the periodic table is 12.01 for carbon and 1.008 for hydrogen. And molecular weight refers to the sum of the relative atomic weights of all the atoms in the molecule. And that is how, in case of methane molecule, where you find the central carbon atom is covalently bonded to 4 hydrogen atoms. And when you're trying to calculate the molecular weight of methane, you have to consider the relative atomic weights of both carbon and hydrogen. Thank you so much for watching my video. I hope you enjoyed it, and I'll meet you in my next interesting tutoring session.